Welcome and thank you for joining us for another episode of the Jane Irrigation Training Series. I'm Richard Restucia, Vice President of Water Management Solutions for Jane Irrigation. And today we're going to be talking about what is smart irrigation. And I love this subject because smart irrigation is a term that is just thrown all around these days and not always accurately. And I guess the definition of accurately, depends on where you are in your knowledge of what smart irrigation can actually be. And so our goal today is to really identify and kind of outline what practices that you would want to have in place, what technology you would want to use, and what products you would want to use so you actually were completing the claim that you were operating a smart irrigation system. And to help us on this journey today is Jim Kauth. He's the president of Aqua Trac in Arizona, and he's a certified landscape water manager. I mention that because it's important because there's less than 100 people with that credential in the United States, and I think less than 5 in Arizona. So when it comes to being an expert, I have real high confidence in Jim. He's been somebody that has worked with ET Water for many years. I know many of his customers personally, and they all rave about the millions of gallons and the thousands of dollars that Jim has saved them as a result of his good work, and somebody who can actually make the claim that he's a smart irrigator. So Jim, welcome. Thanks for joining us today, and help us out here. What is smart irrigation?
Well, it's funny that's the topic because on Google, 28,000 people a month are entering that question. What is smart irrigation?
Yeah.
So there's a lot of people out there that hear about smart controllers, the technology that's out there for irrigation, but they don't know what it is. What does it mean to be, what does smart irrigation mean? Well, in a very simple way to explain it would be to say this. If you have a controller that's managing water and you have to set it for a certain day and a certain amount of time and how many times a week it runs, then basically that is dumb irrigation. Okay, so dumb irrigation is where a user says, whether it's a mom or a dad outside their home or a landscape professional, they're walking up to a timer or a time clock and they're saying, okay, I think it needs 3 minutes every 20 minutes, 5 times a day, every day of the week. That would be dumb irrigation. Smart irrigation says, okay, let's look at how much water does this plant material actually need? So the difference between dumb and smart is there's technology out there now, Richard, that can tell you how much water your landscape requires. So using the technology makes you an intelligent irrigator, which is what we're calling smart irrigation. On the first slide there, I just basically show some basic stuff, which is a smart irrigation controller. There's a picture of a weather station. In one of the pictures, there's a little rain sensor there that collects rain on the wall, that little white thing. Then you have the sprinklers and you have the water meter. So what is irrigation? Irrigation is taking water from that water meter and putting it out on that turf. That's what irrigation is. But you want to do that as efficiently as you possibly can. And that's what's important, is how do I go from the water meter to my yard and give my yard how much water it needs without overwatering, if that makes any sense. So smart irrigation is just simply watering your landscape efficiently. And we know, and everybody knows this, more than 50% of water usage in America is for landscaping. It's not being flushed down a toilet. Also in Arizona, I know in Nevada and California, water costs have doubled in the last 10 years. In fact, one of the main water providers in Arizona has requested a 14% rate increase here in Arizona. We also know that today, with the drought and the conditions of the Colorado River and Lake Mead and the aquifers that we're pumping water out of, that we can't afford to waste water. Let me explain what I mean by this. The state of Arizona and every state has to certify an assured water supply to the federal government, saying that they have water for the next 100 years. If you can't assure the federal government that you have water for your community for the next 100 years, they won't allow you to build another house. They'll stop you. So you can't, no construction happens, nothing happens. So what the states have to do is they have to do what is called a basin sweep. And I don't want to lose anybody on this, but I just want to explain what's going on. What a basin sweep is they have hydrologists go out in the field to determine how much water is left in that aquifer. You know, rainwater that falls into the mountains or comes down the mountains as snow and then becomes water and goes into a lake, that's renewable water. But what the water is that's in those aquifers is not renewable. So if the communities or the states or the cities pump all the water out of those aquifers, well, it's over, folks. You've got no more water. So what they're required to do is they're required to certify every year to the federal government, to the Department of Interior, exactly how much water that they have available so that they can continue to build homes and more people can move into the community. And if you can't assure the federal government through your testing of the aquifers that you have the water, they shut you down. So what's facing these cities in these states that have been in a drought is before we were pulling a lot of water out of the Colorado River, California, Nevada, not so much Nevada, Arizona certainly, and it was being used for farming. So that the aquifer water, which is clean water, was being used for drinking for households. The lake water was being used for farming because you didn't have to treat it. You could just pump it right onto the farm and there you go. But what's happened now is we've had to cut back on the water that we're getting through the lakes, through the Colorado River. So now farmers are tapping into wells and pumping that water out on crops. And now the aquifers are going down. And so there's a real concern everywhere in the United States about these aquifers. So smart irrigation, what it does is it says, I'm going to use water smartly by only putting back what I need to put back, if that makes any sense, okay? So smart irrigation systems were developed really by farming first, because what farmers were trying to do is they didn't want to overwater their crops. Not necessarily they were afraid of wasting water. It would harm the crops if they overwatered. So they were using technology to determine how much water they needed to put on the crops. And then that technology got transferred over to the landscape irrigation industry so that now we're using the technology that began with farming. And so what happens is smart irrigation systems are systems that are either run off of a weather station that says this is how much moisture evaporated out of the soil, or there have sensors out on the property that tells them how much moisture has been depleted out of the soil. So a smart irrigation system runs off of two things, and sometimes both. It'll run off a weather system or it'll run off of a sensor system. So what we have to realize is how much water does our landscape need? Well, the state and the federal government have already figured all this out. They've done all of this work, put together these great algorithms and everything so that no matter where you are in the country, you can figure out how much water you need to be putting back in the soil. The NASA sent off an ET satellite in January of 2015. That satellite covers the Earth. And so that satellite looks at every inch of ground in the United States. some companies like Jane is able to pull that information out of the satellite and figure out exactly how much water needs to be replaced, whether it's on a farm or turf or whatever. But basically what that technology is ET, not the little guy, you know, from the movie, but ET, which is evapotranspiration. So it's an ET satellite, and it goes all over all the world. And other countries have put those satellites out there, and now everybody's sharing the information. So honestly, our government knows how much crops are growing all over the world, and countries know whether or not there's going to be a food crisis because there's not enough crops out there, or whether there's a water issue. So everybody's looking at everybody, what everybody's doing in the farming industry. And this is very important for our population so that we have enough food. So the ET technology has been translated over to smart irrigation for the landscape. So I have a little kind of a display here that talks about ET. So what is ET? So a plant transpires, think of a plant perspiring. What happens is the plant pulls moisture out of the soil. And what it does is that moisture goes up through the roots and it carries minerals in the soil to feed the plant. Then when the moisture gets all the way up to the leaf, there's a stomata there, and then it releases that moisture into the air, and that's called transpiration. It's no different, Richard, than when I'm in Arizona in the summertime and there's sweat coming off of me. That's the same thing. Now, evaporation is easy. That's easy because you figure the temperatures and you can calculate how much water is evaporating. So what is smart irrigation? Smart irrigation requires the use of evapotranspiration. Am I getting this across?
Yeah, you're hitting it really well. And we've got a bunch of questions already. And I'm glad people have already figured out the Q&A in the chat. So
let me go a little further.
Okay.
I won't start talking about flux capacitors just yet. I'll hold off on those.
Stomata might have, that's pushing it.
Anyway, everybody just stay with me, and I'm gonna just show you a few things, and then we'll get right into these questions, I promise, okay? So in this next slide, you can see like the one slide shows soil with no moisture in it. You add water, and then you have moisture in the soil. And I people talk about watering the plants. You don't actually water a plant, you water soil. And a lot of people don't realize that, but you're actually watering dirt because the plants need the moisture in the dirt. So smart irrigation is real simple. Used by the plants, but don't overwater. I think that's as clear as I can make it. And to do that, you need to be watering using ET. And if your smart controller is not ET based, then basically it's just a glorified controller attached to the internet, but it's not using any weather or any kind of algorithm to determine the water usage. You're still just setting it Monday, Wednesday, Friday, 10 minutes for, so many times a day. So, what are the best smart controllers? And this is something, because I work probably with more smart controllers in the state of Arizona than anybody, Richard. I mean,
that's true.
We manage 1 billion gallons, way over 1 billion gallons of irrigation water every year. And when we talk about smart irrigation, there's no way that I could manage that water to the degree that I'm managing it and provide the savings for the facilities that we're providing savings for without the use of a smart irrigation controller. Just forget it. Now, I have in the past, before there was ET water, I knew how to calculate an ET water program so that I would take data and actually write a schedule and go to a controller, a standalone controller, and actually schedule every station according to my ET calculations, okay? Richard, that took a lot of work on me, all right?
A lot of time.
A lot of time. I mean, even to this day, I will still do an ET calculation myself and compare it to the ET controller that's being operated. And so like with ET water, I will go ahead and calculate what I think the runtime should be, how much water I think it should be putting out. And then I'll go on to the computer and see, well, what did ET Water come up with? And what's interesting is that it's always within a minute of what I'm saying.
Yeah.
And I'm always looking at it. And I will say that ET Water is a little more generous in its calculating than I am, because my calculations are tight, and ET Water is a little bit friendlier with the water than I would be. But anyway, so what's the best smart irrigation controller? And you got to have one to be a smart irrigation manager. Number one is you have to be connected to a weather station. I'm going to say this again, Richard. You have to be connected to a weather station, preferably more than one weather station, because if you have 3 weather stations around you, and these weather stations are owned by the state government. They're at high schools or at elementary schools, they're on government buildings, and anybody can tap into them to use them to calculate, because if they're weather stations that will calculate ET for you. So you can get this information into your computer so that you can come up with a schedule. If you just have one weather station and it's pretty far away, well, it might not be a very good determination of what's happening at your property. It'll be better than none, but if you had 2 or 3 and you could kind of triangulate and say, okay, here's what we've got in this area. So again, what I do is I check the weather stations that my smart controller is using, and every once in a while, I'll go and check on those weather stations. Most of them are Davis weather stations, but I'll check on them, and just to make sure that they've been updated and they're running and all of that. So number one is you have to be connected to a nearby weather stations. Now, some quote unquote smart controllers, they are not getting real ET rates. What they're doing is they've been programmed with historical ET rates. So what was the ET rate this month on average for the last 10 years? Well, I understand that. The problem is, what if you have a record heat like we did last year, where you blew out historical ET rates? You then totally underwatered everything and your plant material's dying. So you don't want historical ET rates in your system. You need actual ET rates. What if it's raining? What if the humidity is a big thing, Richard, with irrigation? You can't grow Bermuda grass without humidity. So in the summer months, you might have an ET rate, but if your weather station is showing you a very low humidity, then you know that you have to put more water out there to grow Bermuda grass. Talk to any golf superintendent, he'll tell you, the reason they flood the golf course in the summer with water is not to feed the roots, but to create humidity for the Bermuda to grow. Does that make sense?
Yeah,
okay.
Definitely.
Okay, so you need to be able to receive real-time data from the cloud versus using this historical data. You need to be able to manage the system remotely so that you don't have to stand next to each controller and try to either suspend or program or whatever. So a good smart controller will be connected to the cloud so that you're able to, make those adjustments as the information is brought in. Some of the other things that are real important is you need to be able to tell the controller about the station you're trying to water. It's going to, you should be able to say if it's cool season turf or warm season turf. You should be able to say what the root depth of the turf is. So Bermuda root depth is deeper than winter rye, isn't it? Because winter rye has a shallow root depth. So if you water to a deep root depth in the wintertime, your water has gone past the roots of the rye and you've wasted it. But in the summer, if you do shallow watering, then you haven't gotten down there to water that Bermuda, those roots can go 8 to 10 inches below the ground. So you need to be able to factor this stuff in, whether or not that area is on a slope. Now, why would a slope be important, Richard, if you have turf on a slope? Because you're going to have water runoff. So if you can program into it that you've got, a medium slope, then the computer itself will know, okay, I only need to run this station maybe for 3 minutes, not for 10 minutes, because after 3 minutes, it's all running down the street. So the program itself will run it 3 minutes, maybe 3 or 4 times, and have a little gap between the time runs, so that you don't have that water runoff. And then, of course, you should be able to put in precipitation rates, because as you know, a pop-up spray head puts out a different amount of water than a rotor does. I don't want to lose everybody on what I'm saying, but a smart controller, you should be able to download or program in this thing all these different factors that determine how much water goes on that, either for that tree or that shrub or that turf. Are you still with me, everybody?
We are, and there's one question here that's asking that plays into this point really well. And they're saying, I'm not a plant scientist. Do I have to be, a plant scientist to really do this, operate a smart controller and be a smart irrigator?
No, not at all. So the kind of what you do need to know is it a tree or is it a shrub?
Yeah.
Is it turf grass? Or what is it you're trying to water? Because it's not going to ask you specifically. A good smart controller will say to you, now, is this a desert type of shrub that needs minimal water? Or is this a type of shrub that you would find in Hawaii that's tropical, like a palm that would require a lot of water? So you don't have to be a plant scientist, because a good smart controller is already going to have all that defined for you. And all you do have to do is click which one it is. If it's a pop-up head or a rotor, you just click which one it is. It's very simple. It should be simple for an operator to program. That's the other thing. Good smart controllers should have all this laid out for you, and all you have to do is multiple choice. So I hope that answers the question.
Yeah, definitely. Right. So
Yeah.
drop down with some photos. So I don't even necessarily have to know the names, but I can spot them and easily program it.
Yeah. So now let's talk about what is not a smart irrigation controller, because there's a lot of stuff out there that's called smart. In the city of Scottsdale, they give you a rebate for a commercial smart controller. And what they do is they investigate the smart controller to see if it really is a smart controller. And if it's really using weather data. If not, they won't give you the rebate. So there are controllers in the city of Scottsdale that you have to send to them before you can put it in, and it has to be approved. And a lot of people don't realize that. So a lot of people are out buying smart controllers, and what they're really buying is a web-based controller that they can operate from their laptop, but it's not weather-based. Yeah. Does that make sense?
Yeah.
Okay. So any controller not connected to a weather station receiving live information, data from that weather station, is not a smart controller. If you're not connected to a weather station, you don't have a smart controller. Also, if the controller itself does not calculate the water requirement of the plant. Let me say that again. If you bought a smart controller and you're saying, I want to water this 10 minutes every other day, and you have to determine how much water is being put out, that's not a smart control. Yeah. What a smart controller does, it takes the guesswork out of how much water the landscape needs. You get this?
Yeah, because it's really science, right?
It's science.
It's all measurable. We know what they need. We just have to measure it and then put the right amount of water in.
Right. So any controller that requires you to tell it how much water to put out is not a smart controller. So sometimes understanding what's not a smart controller helps you understand what is. And even if the controller is connected to the internet and it has historical data on it, that's not a smart controller. It has to get real-time data from a nearby weather station.
Yeah, so Jim, I want to ask you about weather stations, right? I mean, I could go buy a weather station for, $20 at Radio Shack, right? I'm dating myself when I say Radio Shack, but I could buy that and connect it up, right? Is that the weather station you're talking about?
No, you have to have a commercial ET weather station. These are massive things. This is not something you bought at Radio Shack, stuck on the side of your house. This isn't like a rain gauge, you know? Remember those rain? Oh, I got one right here.
Yeah.
You know, this isn't this.
Right. Yeah.
That's not a weather station. And when we talk about weather stations, these kinds of weather stations I'm talking about, a lot of the golf courses have them. You know, these are $10,000, $20,000 weather stations. Certainly all the schools have them. The state has them throughout the state. You can go on any state and find their weather stations, and you can pull data down from it.
Right.
So.
Right. And I mean, we're even using satellite imaging, Doppler radar too.
Right.
I mean, we're really fine tuning the weather side of it.
Yes. And here's the thing. Now, all of this, now let me just explain this to you. And I hope I don't lose anybody. Okay. So the ET rate is determined by an equation that was developed about 35 years ago. Okay. So the ET rate that you're pulling off of weather stations will always ensure that you're overwatering a little bit, Richard. Okay. So just because you have a smart controller, you can't set it and forget it. Because you'll find that that smart controller will water more than what is necessary because it has a default program to do that. You as the individual have to, as a smart irrigation manager, you know this, and so you have to make adjustments on the fly, but only you adjust what the controller wants to put out. So if the controller wants to put out X amount of minutes, then you might make adjustments to that, but those adjustments are made different ways, and we're going to get into that. How do you adjust a smart controller? By the way, if you have a controller and you can't make adjustments to it, like I'm going to show you, it's not a smart controller.
Yeah.
Okay. So let's just talk about that. So first of all, the truth. 90% of smart controllers are not being used properly. I'm sorry, but they're not. We go onto properties, we do audits throughout the state of Arizona, and we'll find smart controllers installed. But what has happened is they've been dumbed down, Richard. What I mean by that is they're not connected to the weather station. They disconnected it. They're not getting real-time updates on what's going on. And what the landscaper has done, or whoever's running it, may not even be a landscaper, could be a facility manager. They're just basically setting it like the old one was, you know, to come on Monday, Wednesday, and Friday and run for 30 minutes. And when I say to them, why did you set that? Why did you make that the program? What was the science behind that? They just look at me like, you know, like a deer in headlights, you know, like, what do you mean? I said, well, you set it for Monday, Wednesday, and Friday to come on for 30 minutes. Why not 40 minutes? Why not an hour? Why not 10 minutes? Why did you set it for 30 minutes? And nobody can ever answer that. It's just whatever they think is best. Well, that might not be best for the landscaping. Is that making sense? So
Yeah.
go ahead.
I'm curious as to why they're taking them out of the smart controller mode, right? Because that's what they're doing. They're taking a smart controller, they're dumbing it down. And why do they do that?
Because they haven't been trained on the technology. So if they had training and they were shown how to use it, they would be like, oh my gosh, I'm making this a lot more work than I need to. So what you're saying, Jim, is I only need to make slight adjustments and let it go. I go, that's right. And you'll see all the savings that you want. But if you take it off of its smart, take the smart out of it, and you remove it and you make fixed schedules out of it, well, you know, you just might as well have a 40-year-old time clock out there. Is that making sense?
Yeah. Yeah.
So we don't want to dumb down smart controllers. So the reason why people are doing it is because there is a gap, Richard, between the technology and the training. When we go on a property and we install smart controllers, whether it's a golf course or a facility or whatever it is, in all of our proposals, we propose to train the landscaper or the facility manager or somebody on the use of the technology. Then we provide them with a year of backup. So at any time they need us, we're on the phone, we can help them. We also are able to look on the web at what they're doing with it. And if I see something that's amiss, I'll call them on the phone and say, hey, I don't know why you're watering those 50-year-old trees in the wintertime, but you need to shut the water off on those trees. You know, there's no reason for that. And normally the answer is, I didn't even realize I was watering it. So what happens is there's a gap between technology and training. And that's the issue. So we don't do any landscaping. We don't sell any products. We basically manage systems and do audits in the field. But we do a lot of training with a lot of landscapers. We provide a lot of training on how to manage these smart controllers.
Yeah, so if I'm a landscape contractor, I can reach out to you, maybe do some
Yes,
contract for some training, or maybe
yes,
work side by side with you or your team for a while and
yes,
kind of learn how to properly use these smart controllers.
yes. And now we do that. Usually a landscape company or a facility will have somebody that they have that manages the water, that they, you know, because the water is so expensive now, they have people. So we usually work with that person, and that's something they have to pay for. However, twice a year, we provide free training to any irrigation tech in the state that wants to learn how to operate and inspect an irrigation system and make it efficient. So we provide training to irrigation techs for free, and it's bilingual. But for, if you want us to show you how to operate a system, how to manage a system, then we, of course, we charge for that.
Yeah. And Jim, in your opinion, why aren't more contractors embracing this, right? It would be making their jobs easier.
Here's what the problem is usually we walk on a property because the water bill is through the roof, and the Arizona Department of Water Resources has sent them a nastygram saying that you've gone over your allotment, do not pass go to jail, right? Because the fine is $10,000 an acre foot of water. So usually when we come in, the landscaper feels threatened by us. But I don't even own a lawnmower, Richard.
Yeah.
Right? I don't even have a wheelbarrow or a shovel. We don't do this. We're coming in to figure out how can we turn this thing around. And what we want to do is work with the landscaper. And normally what happens is we do an audit. We have a punch list of things that need to be done to make it more efficient. They take care of the punch list. Of course, they get paid for all this, right? And then what we do is recommend to the board or the facility, you know, what changes need to be made so that you can dial back this water cost. Well, we don't sell equipment. So when we walk on a property, we walk in as consultants. We're there to turn it around and to help the landscaper. So what happens to landscapers, initially, they feel threatened by us. Once they get to know us, well, they love us because they get to keep the property and the water bill goes down and they all look good.
Yeah, I see, as a landscape contractor, I see two ways to go. One, find a good partner like Aqua Trac. Because again, you know, if I was an auto repair facility and I could bring in a third party to say what's wrong with my car and then have the auto repair facility fix it, right? Then I've got a independent opinion of what to do. And that's really good for me and my customers. So I like that. I also worry though that these contractors, if they don't educate themselves more quickly, if we look at the energy industry and what's happening in commercial buildings, right? You have energy management companies coming in and taking that business away. And I don't want to see the landscapers necessarily lose that, so they can educate themselves or partner with a good company like yours. And I see that's the way we can keep this within the landscape industry.
I agree. I mean, we partner with some of the big boys too, so it's not like they're not doing it. But what I would say is this, is that the first thing a landscaper has to do is be honest with himself. And what I mean by that is you have a website that says you do water management, you do this, you do that, you do all of this. Well, the bottom line is that the culture has changed. Water is liquid gold now. And you're going to be responsible for that water bill. Whereas in the past you weren't. Today you are. So you need to have the tools in your toolbox as a contractor that you can pull out to fix that problem. Having Aqua Trac in your toolbox as backup, because when we work with these contractors, we may work with them on a specific property and help them, but they're calling us all the time on all kinds of properties. What do we do here? What happens there? What about this? How do we do that? What do we do here? So what we try to do is partner with all these people, right? So that the end result is the water bills go down and the health and the vibrancy of the plant material goes up. And they're able, we've worked with landscapers that were able to keep properties, keep them in their portfolio. And when they go to bid, you know, the position is, hey, you know, they saved us $250,000 on water costs. They did this, they did that. It's going to be very difficult for you to walk in there and say, we can do a better job than Aqua Trac or this landscaper, when for the last 5 or 6 years, the facilities or the board of directors have seen the tremendous, you know, results of what's happened, because they put out a lot of money, Richard, to buy and upgrade their systems.
Yeah, talk about, it's hard to find another industry where you can have such a compelling argument. We saved water, we saved money. Go look at the property. Tell me what you think. And, you know, in the landscaping industry, you know, point out the properties you do work on, and that's your best selling tool.
Yes. And I think what happens is, and I'm just trying to get landscapers to kind of look at both sides of this, is you're trying to keep a client, okay? And you're not realizing how important water is to this equation. And you think it's just mow, blow, and go. And you bid it that way. Now you're realizing, man, it's going to take a lot more cost on my end to really do a good job here. And what poor landscapers are having to deal with is, if they bid it correctly, so they can do the good job, somebody comes in and underbids them.
Yeah.
So what we do is we educate the landscaper on how to make the presentation and how to show them the difference between apples and oranges. And every time we've done that, they've always gotten the job. They'll pay more to get better service. They will, Richard.
Yeah. Oh, absolutely. I know that, I've experienced it, and I think more people are understanding it today.
Yeah, yeah. Okay, so smart irrigation 101. Okay, so let's say you want to be a smart irrigator like me. What are some of the things you need? Well, number one is you need an ET smart irrigation controller. Did you get that? ET, okay? If it's not getting real-time ET data, you have a dumb controller. That makes you look dumb. The other one that you should have, or would help tremendously, is flow sensing. Now, what do we mean by flow sensing? Well, here's a very simple explanation. So when you have an irrigation controller and you have a flow sensor on it, and all of a sudden a valve leaks and you're not running a program, it senses the flow through the valve because the valve's leaking. So it sends you an alert and it says you got a valve leak. Very simple. You can say to I can call a landscaper and say, hey, valve controller 42, valve 13 is leaking. Oh, okay, we'll get to it. Okay, great. It's not major, but you can see the leak in flow sensing. The other thing is, if you have a broken head or a broken lateral line, flow sensing will just give you an alert that, hey, you know, this water normally runs at so many gallons per minute, and there's been a change and it shot up. And it shot up like 25%. And, you know, that tells you, okay, we need to send a tech out there to go investigate that to find out what's wrong. The other thing you want to have in your toolbox are fixed nozzles. I can't tell you how bad adjustable nozzles are in a pop-up sprinkler. I mean, any irrigation contractor that's listening to this or watching this, or any homeowner, get rid of adjustable heads, because every time they pop up, they adjust in the wrong direction, right? If you get fixed heads, that means they spray out in one direction and they're that way. Every time they pop up, they spray out. If you get the adjustable kind, They don't. And it's, if you're watering the street instead of your yard, okay, the grass doesn't grow in asphalt. I just figured that out. So you need to change that. And then the last thing we have is a multimeter. If you don't have a multimeter, then you can't be a smart irrigation controller. So why do you have to have a multimeter? Because if the controller doesn't work, that's what you use to determine whether it's not getting power, or it's not putting out power, or if the solenoids have gone bad, or all of that. So all of my techs in the field are trained on smart irrigation controllers. They're trained on hydro flow sensors. They're looking for fixed nozzles out in the turf, and they all have multimeters and even more technical equipment with them. So if you want to really be a smart irrigation person, and you have an ET smart controller, and you've got flow sensing, and you've already got those systems in place, then there's one other thing that you have to do to be a smart irrigation controller, irrigation person, and that is to inspect the system, Richard. And Richard, nobody does it. Nobody. So you got to go out there, you got to go to the controller, you got to turn the systems on, go out there, walk the property, what's working, what isn't working. 50% of the savings that we generate properties, Richard, 50% are because of the inspection systems, the proactive inspections. These inspection systems are super important. For instance, on this page I'm showing, this is just one of my techs a couple days ago, went out and did some inspection. So look at the pictures. The valve's broken, there's a lateral line damage. There, valve 7 is a broken rotor. We have a valve leaking. We have a thing spraying out. So this property has a smart controller. But Richard, if these things don't get inspected and repaired, the smart controller doesn't help us. So you can't have just smart irrigation. You got to have smart irrigation techs.
Right. I absolutely, and especially because a lot of the irrigation takes place in the dark when people aren't around to see it. ET water smart controllers, they'll give you an alert that you've got a high flow, and they'll shut the zone down and won't turn it back on. But somebody who doesn't go out and fix that, you're going to still have the problem. And I agree. I think the inspections are so important, and they've got to be regular. It's got to be part of the routine.
Right. Just, you see what it is. An ET controller, Richard, is taking weather data, and it's being proactive. Let me explain what it does. It takes this weather data and it puts together a program 1 week forward. Okay. That's proactive. It's assuming that this is what it's going to be. Now, each day it gets new information. It can change that, but it will put together a program that's proactive. This is how much water should be put out based on the information that we have. Well, when you're doing inspections, you're being proactive. You're not waiting for the water bill to come in and see it's gone through the roof to go out there and find a mainline leak. You're not waiting to see something. You're going out there in the field and you're testing it. Every day, I have technicians all over the state of Arizona. They're inspecting controllers, they're inspecting valves, they're testing solenoids, they're testing master valves, they're out there testing flow sensors, they're doing all of that. Every month, I have technicians out there inspecting water meters, Richard. So why do you think we inspect a water meter?
Yeah, well, I think you have problems with your water meters too all the time.
Yes,
right?
you do. Yes, you do. We've had water meters spinning and no water moving. Yeah. We had one water meter at the Arizona Grand Resort produced $150,000 water bill.
Yeah. Wow.
And it wasn't even running. And they paid it. And after they paid it, the facility manager said, wait a minute, hold on, what? And then they called us to do an investigation. So we went out there and did a water meter audit and found that they had water meters that were spinning and no water running through. So we have to inspect the water meters. But what we're really doing, Richard, is what we do is we open up a meter box, we're looking at the water meter and we're turning on the master valve without turning on any of the valves. And we're seeing if we see any spinning. Yeah. Now we know we have valve leaks down the line or breaks in the line. So we want to do water meter inspections all the time. And then of course, we do soil tests. Why do you do a soil test? Well, you need to know what minerals or fertilizer it needs. And we also do soil tests on moisture. We check the moisture in the soil. So we just want to say is, okay, if this is saturated, is it really saturated? So we'll do, you stick the thing in the ground, you turn it, you pull the plug up, and we send it in and we get all that information off of it. So inspections are a big thing. This may be more than what anybody on television is watching right now, and the world of the World Wide Web really wants to get. But I'm thinking if I can just get some people watching this to say, you know what, Jim's right. We need to also do inspections. Besides that, I think it would help.
Yeah, I think the other thing that's important, Jim, to point out too is that if you've got a turf area, it's a turf area because people are there playing on it, sports or recreating on it or jogging, and accidents happen all the time, right?
Yep.
Things get kicked, things
Yep.
get, it's not, it's from normal wear and tear, especially
Yes.
where you have a lot of people using it. So
Yes.
this is why it's so important.
Absolutely. Yeah. And broken heads are normal, Richard. That's what you should see. Every time you do an inspection, you should see things that are out of adjustment. That's nothing bad. That's what you're looking for, right. Now, let's say you've got an ET water controller, Richard, and you're out there and you want to make adjustments, okay? See, now, if you have a dumb controller, then what you do is you have to go back to the thing, find that station, turn it over there, adjust the minutes up and down, because you want to make an adjustment. Well, you can make adjustments to an ET water controller that you can't make to a dumb controller. And we're going to talk about those adjustments. Now, I'm kind of giving some of the inside secrets of how we manage ET water controllers. So, I don't want to see anybody that's watching this show going out there and selling my ideas, on the internet of this is how you do it, but this is how you do it. Just joking. There's a thing called depletion. So there's a depletion rate when you have an ET water controller. But what happens is you're telling it when the water gets, like, let's say the root zone is 6 inches. You say to the ET water controller, once you get down to 3 inches or 50% depletion, turn that water back on and fill that back up, right? It's kind of like this. No, not like this. Like this cup of water right here. Okay. So the water's here. When I drink it, it drops down there. Now, what I'm going to want to do with my irrigation is just fill it back up to that point. Okay. Now, I can go on an ET controller and I can set different depletion rates. So a depletion rate on winter turf is much less than it is for a tree, because a tree might have a 4-foot root depth.
Yeah.
So I can deplete that 2 feet, right? But winter turf has that much of a root depth. So if I don't ever want to go down to 50 or 75% on that. So I constantly want to keep that filled up for winter turf. Okay. The other thing is the root depth. On an ET controller, you can determine the root depth. If you have a new tree that you just planted and your root depth is only 2 feet, well, then it's 2 feet. But if you have a mature tree, it could be 8 or 10 feet, right?
Right.
So you can let a 10-foot root depth go for a long time, Richard, before you have to fill it back up. Whereas a new tree, you got to fill it up pretty quickly. The other thing is water budget. So let's just say you can do a water budget adjustments. Now, a lot of the dumb controllers also have a season adjustment. That's pretty much the same thing, where you could just cut the whole thing back across the board 50%. We don't use this water budget much unless it's on turf, where we're trying to maybe overseed turf and we want to throw more water out there than what the ET controller is saying, because we're trying to develop that seed to get it to germinate. So we'll use that. And then, of course, on turf, on an ET water controller, I can adjust the slope. Yeah. So if I want the water only to water small periods of time, like 1 or 2 minutes, I increase the slope. If I want it to run more at one time, I can decrease the slope and make the computer think it's a flat surface. But normally what we do is we increase the slope because what we're trying to do is it's the same amount of time, Richard, it's just shorter intervals. Does that make sense?
Yeah, a lot less runoff that way.
A lot less runoff. And the reason in the winter you want to do this with winter grass is because the sidewalks around the grass, if they get wet and stay wet and you have freezing temperatures, it turns to ice and people can slip and fall on the ice. And we don't want that to happen to anybody. So in the wintertime, if there's a possibility in Arizona of freezing temperatures, we'll bump the slopes up and so that the intervals are much shorter, you know, and so we don't have that any kind of runoff onto the sidewalks. So that's kind of a technical thing there.
Right.
Yeah. Okay, so here's my biggest secret. And Richard, I don't know if there's any way that you can get everybody to swear never to disclose this, but this is my biggest secret of water management.
I know, Jim, we've got a few hundred people watching today. So
well, they're going to say it.
Out.
Okay, here's the deal. If you ever use my secret, you have to say, this is Jim's secret. Okay, that's all you have to do. You just got to give me credit for it. Okay. The biggest thing to saving water and managing a smart controller is shutting them off. Yeah. Now, in the past, when I had all these standalone controllers all over Arizona, Richard, it was like a fire drill when it was raining. I had people everywhere. We were jumping out of cars in the rains with umbrellas, running up to controllers, opening them, putting them on rain delay, shutting them. Some of them we had to just simply turn off because they didn't have a rain delay, right? None of them had rain sensors, literally hundreds of these things. When it rained, I was a madman all day just shutting down systems. Well, the great thing about an ET smart controller is I can sit in Hawaii on the beach, right? Yeah. And I'm getting weather info and I can just hit a button, bing, and I've just shut down all of the state of Arizona so there's no water. I don't know about California where you're at, but in Arizona, if you drive down the street, they have these signs, these digital signs that tell you accident ahead, blah, 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 you know, all this stuff. I wrote them and said, listen, when it rains, why don't you put a sign up that says, shut off your irrigation?
Yeah.
Because just to give you an idea, on one property every day, just this one property we manage, on one property every day we have the irrigation shut off saves $4,500. Yeah. On another property, $1,800. On another property, $1,200. So the biggest secret to managing water smartly is being able to go to an ET controller and you don't have to shut it down. All you have to do is suspend it. And then the great thing about a smart controller, it'll say, oh, you want to suspend it. You've got some rain. So how long do you want to suspend it for before you want me to start watering again? See? So I can say, well, this was a pretty good rain. Suspend it for 4 days and don't water anything. Or it was a little rain, suspend it for 2 days or for 7 days. But I can also tell ET Water at the end of the suspension, consider, right, that the soil is depleted 75% or 20% at the end of the suspension. Otherwise, other controllers that are not smart controllers will try to re-water all that time that it's been shut off when it turns back on. And you don't want that to happen. So if you turn a controller off and it stays off for a week and then it comes back on, you don't want it to try to water in a couple of days, that whole week of water that it missed. So a smart controller will understand that it's being suspended because of rain and it won't try to go back and water. Does that make any sense?
Absolutely. And I thought it was really generous of you to share your greatest secret.
I know. Yeah. So I would say that the more often that you can shut the irrigation off, the better and smarter you are as an irrigation manager. Of course, when it rains and in the wintertime, this stuff should be shut off anyway. Some irrigation systems are winterized, but the greatest secret is Well, in the city of Scottsdale, Mesa, Tempe, those three, if they see you running water while it's raining, you get a $150 fine.
Yeah.
So they do that in Nevada as well.
Yeah. Well, and they should.
Yes.
Right.
Yeah.
I mean,
Yeah.
it's too valuable of a resource to be wasting right now.
Yeah. I don't know, Richard, do you think this answered the question? What is smart irrigation?
Boy, I think you did. I think you did a very good job on this, Jim. And we're going to send out an email with a copy of the video or a link to the video to everybody who attended today. We'll go ahead and put your contact information in there as well, so that if they have questions or want to work with you in Arizona, boy, they should give you a call, right?
Yep. Yep. I'll help them any way we can.
Okay. All right. That's great. Well, listen, thank you so much. You're always such a great guest. So interesting and knowledgeable. We really appreciate your time today. And for all of you watching, thank you for watching and helping us promote this whole concept of sustainable irrigation. We're always looking to conserve. So thank you. And next week, we're going to have a couple lunch and learns Wednesday and Friday. Wednesday is going to be on telemetry. What is telemetry and how do you use it for water management? And then Friday, we've got Charles Fishman. He's going to be talking about his book, The Big Thirst, which was published almost 10 years ago to the day. So he'll be talking about the success of that book as well. So Jim, again, thank you very much. Everybody, thank you. Have a good weekend, and we'll see you next time. Thanks.